Okay, so good afternoon, everybody. It's a great honor to have Dr. Laurie Williams here today as our inaugural POSE Distinguished Lecture Speaker. I will summarize her bio, but in a nutshell, Laurie is the world leader in open source software security research. She's a distinguished university professor in the computer science department of the College of Engineering at North Carolina State University. She's the director of the NSF-sponsored Secure Software Supply Chain Center and co-director of other centers like the NSA-sponsored Science of Security LabLab, the Cybersecurity Excellence, and the Secure Computing Institute, all at North Carolina State University. Laurie is an IEEE and ACM fellow. Her research focuses on software security, software process, and empirical software engineering. Without further ado, Laurie, the floor is yours. Oh, you are muted, Laurie.
Okay, there we go. Okay, we'll begin again. Sorry about that. We weren't muted before. So I'm thrilled to be here with you today. And what we'll be talking about today is software supply chain security. So if I put this into context.
So Laurie, 1 second. I cannot see your slides. Jeff, can you see her Laurie's slides? It shows started screening, but I cannot see.
Yeah.
Hamad, can you see it?
Try it again.
I do not see it as well.
Try the share again.
Yeah, of course, it worked perfectly when we practiced, right?
It's always like that.
Let's try it. Let's see it now. No?
Yes, I can see it, but it's
We can see,
preview,
but
if you
it's
can
in
switch it.
presenter. It's in presenter mode. You know when you see the next slide.
All right.
Okay, now we see presentation mode. Fine.
Okay. All right. Take 3. So today we'll be talking about software supply chain security. And so put things into context. Most commercial software, it has a lot of third-party software in it. A lot of studies say maybe 80% of a typical software product is made of third-party software, which especially includes open source software. And so what this iceberg chart is showing here is like below the line, most organizations have a lot of third-party software, open source software, and the innovation, the software that differentiates one product from another is what an organization develops themselves. And so this third-party and open source software is critical to innovation and competitive advantage. If companies had to develop all of the software themselves, everything would grind to a halt. But the supply chain is turning into a big attack vector. This graph here shows there's an organization, Sonatype, and this is the growth chart of malicious packages entering the open source ecosystem. So you see over the years, just almost exponential growth of the open source software having, and the keyword is malicious, as we'll talk about. So using it as an attack vector. So within software development, one key aspect are these packages that people bring in, third-party packages. And for all time, there can be mistakes that are made. So there's an open source software developer and they make a mistake. Like Log4j is an example of that. Like Log4j, the mistake that enabled the Log4j attack was just a mistake on the part of the development team. And so for all time, attackers have been searching around, trying to find vulnerabilities that are accidentally put into software components and then exploiting them. But what's new related to software components coming out of the open source ecosystem is intentionally using these dependencies and code projects as an attack vector and as a weapon. So intentionally putting malicious things into the ecosystem so that development teams download it and then they have an attack enabled. An example of this, Node IPC, and was when the Russia-Ukraine conflict just began, and someone put into the Node IPC component some code that would down or delete files if someone came from a certain IP address. So this is an example of using these dependencies as a weapon. This is new, and this is what we see high growth with. Another new attack, newish, now it's a few years, but a newish attack vector is the build infrastructure. So when a project is being built and compiled and deployed. And so some big examples of that we've all heard about are SolarWinds and CodeCov. So using this build infrastructure attack vector. And another novel attack vector related to supply chain security is related to large language models, LLMs, ChatGPT, and the code that can be generated from them, and just considering how can that be used as an attack vector. With all of this growth in these attack vectors and supply chain security, back, now it's all the way May 2021, so it's been a bit of time, but there was an executive order on improving the nation's cybersecurity, and a certain big section of it was specifically focused on the security of the software supply chain. And so that really has turned a lot of organizations towards looking at the supply chain. And as with all of the news and what's going on in the executive order, a lot of practitioners have two basic questions. Okay, it's a problem, but what should we do? And also, what's everyone else doing? We don't know what to do, but tell me what everyone else is doing, and then that will inform us on what we should do as well. And so in order to answer those two questions, and do security science on this software supply chain, I'm going to talk about two different forms of empirical studies that we've done. And one thing at this point in particular, most things have been done under Chatham House rules, which says that I can't tell you who is involved with the types of studies that I'm going to talk about. But just trust me that these are large organizations for the most part. We do get small organizations as well as a balance, but the majority of the people involved in the studies I'll talk about are companies that you know about. So one form of study is what we call the Secure Software Supply Chain Summits. We've had 7 of them since 2021. I'll tell you what they're about in a moment, but as far as who's been involved in these summits, in these 7, there have been 55 industry practitioners involved. 8 of them have come to 2 summits, 2 have come to 3 summits, 37 different organizations, 26 government practitioners from 13 agencies. So a good cross-section of people have been involved. And when we have these summits, they're a full 8-hour day, consisting of a keynote typically done by the host. We have hosts from around lots of the different companies. One will host and they get to do a keynote, and then we have a number of different panels. The topics on this slide are the topics of different panels we've had over the years. And so a lot of these are very topical for supply chain security, the executive order, software bill of materials, dependencies, and whatnot. And the way we run these summits is we'll have 4 people from industry or government talk about what is their view on a certain topic, just for 2 or 3 minutes, and then open up for the floor. One thing I hadn't mentioned is when we have these summits, they're small, about 15 companies, 1 person per company per summit, so that we can have a really nice intimate sharing, as opposed to a large audience where people just talk about the shiny objects in their own company and want to look good. But when they're a small organization, smaller group, people are pretty honest about the challenges they're having. So like, as far as the summits go, just listening and identifying the patterns of what people are doing and what the challenges they're having. Another study that I did, and this one, particularly in conjunction with Synopsys, is a very large scale interview study, 9 companies, 7 of them large companies, 2 medium. And I will classify, I'm going to give you some very specific information about the practices used by these companies. But I will say that I would view all of these companies as early adopter, progressive companies, really caring about software supply chain security, knowledgeable, having explicit action. And so the results that I'll show you are probably not completely representative of all of the companies out there. And you'll see the pictures are concerning as it is. So there was 61 people who interviewed, and one was a chief information security officer. 27 were in the area of governance, which I'll say these are people who were in a software security group, risk management, vendor management type of people. 23 were in, I'll call them product people, architects, developers, and testers, and 10 were in environment and deployment groups, such as DevOps, product security, incident response, IT types of organizations. And so what really we're trying to answer with this interview study is, part one is what should we do? So what should we do? Supply chain security, what should we do? There have been a lot of guidance given to organizations about what should you do. On this slide are some examples, especially people are focused on the NIST SSDF, or Secure Software Development Framework. SALSA is another guiding document that people look at. NIST 800-161 is specifically on cybersecurity supply chain risk management. So organizations are looking to these documents for guidance on what to do. There's also the S2C2F on the upper left, supported by the OpenSSF, originating from Microsoft. BSIM 13 comes out of Synopsys. Cloud Native has a supply chain best practices guide. OWASP has the software composition verification standard. And so to structure the study, I came up with what I call the proactive software supply chain risk management framework. And what I did was take all of these frameworks and standards and guidelines that everyone's looking at and bring them together into one document. And the list of, what's in these blue circles kind of evolved over time as I was doing interviews. Like, for example, what's up there is CNCF, Cloud Native. Like that wasn't initially in the framework, but then as I was doing interviews, I was hearing more and more often that people were looking to that for guidance, and then I brought it into the study. So this proactive, so the PSSCRM framework is like, I have a large document I'm happy to share with anyone, and it has what you'll see 73 different tasks, 73 different things organizations should quote unquote do according to any of those documents in order to secure the software supply chain. So in this PSSCRM, I used bidirectional equivalence, which was recommended by Karen Scarfone of NIST. Bidirectional equivalence is basically saying the different documents are giving different names and descriptions for the same thing. So that's how they can map together. And so like, here's 3 specific tasks. Like if you look at the attestation task at the bottom, then it'll show you all of the different frameworks and specifically with an identifier of what framework says you should do that attestation. So for all 73, there's the mapping to who says you should do that. And so ultimately, like I said, 73 tasks, and then I did some organization of the tasks into 15 practices, which are down in the blue, and 4 groups, which are the columns. So the different groups are governance, product, environment, and deployment. So in the governance task, you see there's compliance, security policies, managing suppliers, training, managing risk. Under the product category are security requirements, building security in or software security practices, managing component choices, discovering vulnerabilities, managing vulnerable components. And in the parentheses are the number of tasks. So each of the bullets in the columns is a practice. And then in the parentheses are the number of tasks that mapped to that practice. So we're using this framework. I gave each of the tasks a unique identifier, like group. The first letter P for is for product, and that's the group. And then the next number is the practice. And then the third number is the task. So each of the 73 practice or tasks has its own identifier. And so now I'll start to tell you about some of the observations. So the empiricism that came out of here. To answer the question of what is everyone else doing? And again, this is based upon 9 companies that I worked with. And so each of the 15 practices are on this spider chart or polar diagram. If you look at the upper right, there's a grid there, and the point of the grid. So after I did the interview and I asked about someone in an organization about each of the 73 practices, I gave the company a grade on how well or how much they're doing that task. And so 0 said not doing it at all. 0.25 says it's emerging, like we know we should be doing it. We're kind of getting ourselves going on it. 0.5 is progress is being made. We're actually implementing this task. 0.75 says, we're getting there. We're almost there. And then 1.0 says, we've got this one. We're doing it. Someone else can follow our example. And so if you look at this polar diagram and look at the trends, so some of the areas that, if it goes into the middle of the circle, then it's more towards the don't do it side. And the further out it goes, the more companies have adopted it. And so if you look at some of the lower ones like P5, which is component and container management, is low. Also P3, component and container choice, is low. And those numbers in the parentheses are again telling you how many tasks are in that practice. And so we'll revisit this component and container choice later, but you can see, it's on the lower end. Also compliance is on the lower end. And then you can also look at some of the things that are higher. So like some of the things that are higher, people are training. So G4 is training. E3, development environment, doing a pretty good job at having the development environments be secure. G2 is policy, doing okay there. Discovering vulnerabilities, again, kind of, on the high side. So you can kind of get a picture. And when I worked with the company, then they would get this picture, this shape, and then their own as a comparison. So they could do a gap analysis of how they're doing versus how everyone else is doing. Okay, so this is a summary of the tasks that have been adopted the most by the 9 organizations. And the color scheme is based upon the group. So black is governance, orange is product, green is environment, and 1 is deployment. And so some of the things that organizations are doing pretty well. So authentication, at least we are authenticating people before they get into systems. The employees and contractors have to authenticate. And then also having, and this is the key, having automated security scanning tools. So having them, not necessarily running them, but having them. Role-based training, build output says that when a product is built, the output is put in a different place than the source code. Having roles and responsibilities for security, boundary protection, which enforces the need for certain steps. Software licenses, so companies are pretty good at checking the software licenses of components that they bring in. Protection of information at rest, so doing pretty well with encryption, disclosing vulnerabilities pretty well, and separating environment. So the development environment is separate from the build environment, for example. Here's the ones that companies really are not doing very well. The bottom one is reproducible builds, which is kind of a novel practice that's come out of supply chain security, where organizations build a product twice and then do a bit by bit comparison of the two builds for the purpose of identifying whether tampering has been done in the build environment. So for the most part, people are not doing it and not even thinking about it, because 0.03 says, 0.25 says we're emerging. So maybe one of the 9 companies said emerging, the rest of them not doing it at all. Consuming SBOM. So the executive order stipulates that in order to sell to the US government, an organization needs to produce a software bill of materials. But nothing said, and so that practice or that task has been, it's on its way. Organizations are on their way to producing a software bill of materials. But this is saying that they don't consume them. So they're getting the compliance checkbox, if you will, of producing a software bill of materials, but not really doing much else with it. So then the next one is required sign commit. So the things that they bring into their organization generally don't require that those are signed. Deliver provenance. So producing provenance information is something that people are starting to look at, but actually delivering it or giving it to someone else, not really. Prevent component vetting bypass. And we'll talk about component and component choices a little bit more in a moment, but I'll show you that there's practices that should be put in place in order to protect from malicious components being brought in. And what this is saying that you could put a process in place, but it's pretty easy to bypass that. Produce attestation, which is, we'll again talk about that some more, but producing information that would attest that an organization does use a good development process. So that's not being done quite so much yet. Build process monitoring. So like, is someone in your build process, like the Code Cub and SolarWinds, like, is anyone monitoring what's going on in the build process? Not really. Not delivering software bill materials to anyone. Not really having ephemeral credentials, so software short-lived credentials. Not using compilation and build defensively to identify malicious activity, and not using trusted repositories. We'll talk about that again some more in a moment. So these are the bottom ones, and it was bottom 11 because there's a tie, two-way tie at the end. All right, so now what I'm going to do is go back through. I told you about the different attack vectors at the start of the presentation. One of the attack vectors in the supply chain is the actual components that come out from a third party, whether it be purchased or open source. And I mentioned that sometimes there was accidentally put vulnerabilities in, also maliciously put vulnerabilities in. So in that category, how are we doing at adopting tasks that would help to prevent this type of attack? And my, key takeaway is that the class of tasks that would prevent that attack vector are not been adopted yet. And so I put this as a danger zone. And on the right here is a nice visual that came out of a government document that's listed on the bottom right, securing the supply chain, recommended practices for developers. And really the recommended practice here is if a developer wants to bring a component into an organization, that component should be downloaded and scanned by, a vulnerability scanner, particularly a software composition analysis tool, which can look at whether there's vulnerabilities in there, and then can put the, if it passes that, it can be in a secure repository, and then, continuously scanned, issues found. But in particular, an organization should have a development repository, a safe place to put these scanned and chosen components. And so that's like kind of the recommended practice. But if you look on back in the middle bullets, the tasks related to manage component and container choices are really, for the most part in the not being done yet or emerging phases. So the first one, component and container choices, says like, is there an approval process for bringing something in? Do you have the trusted repository, which is in the figure over there on the bottom? Do you require signed commits? Do you only choose components from vetted third-party repositories, or can you go to anyone's website and just pull a component off? And then preventing component bypass. So the average adoption of those that really are focused on managing component container choices, the average is 0.23. So on average, we're just not even quite into the emerging phase yet, even though it's a really important attack vector. A related one is P5, manage vulnerable components. So these are components you already have in your product, and then managing them as they become vulnerable. And so there's two tasks in that practice, software bill of materials consumption, which basically isn't being done yet, and then dependency update. So you find a vulnerability is in your dependency. How do you manage updating it to a new version that is a safe version? And it's in the it's 0.44, so it's sort of happening, but still pretty low. And then another one is in the environment test, more like IT build kind of phase, and verifying dependencies and environments. So this is like in the build process, do you make sure that you're getting things from trusted places and whatnot? That's quite low as well. So my concern about this is that there's a major attack vector in the components, and 2 years after the executive order, there's still not a lot of adoption of the things that could close down that attack vector. Another key takeaway in this area is that the third-party vendor compliance, so putting onto a vendor, you need to have a good software development lifecycle. You need to produce the software bill of materials, like having these stipulated onto your own vendor is also still pretty low. So these types of attacks can continue. The other attack vector I talked about, which is using the build infrastructure as an attack vector. And similar, I also put this in the danger zone. So the adoption of these tasks is dangerously low as well. So there's an environment practice safeguard build artifacts, has 7 different tasks in it. And then the average of all of those is 0.42. So, really not even halfway there. And even that 0.42 is being brought up by E27 build output, which says, when you build a product, you don't put the built artifacts in the same place as the source code. And most people have done that. If you take away that 0.94, the average would be even lower. So as far as just taking steps in all of these tasks in order to protect the build infrastructure, really not adopted very high. Another attack vector that I talked about earlier was LLMs or ChatGPT, and there's a lot of concern about tainting the data for code generation and aspects like that, and companies are absolutely concerned about that. But when I asked them, what are you doing about that? What are you doing about the fact that the training data could be tainted and the generated code could have vulnerabilities in it and whatnot? And none of the companies really had a new specific task that they did just for that. So what they were doing was more static analysis, more fuzzing, more software composition, like just more of the same, in order to check whether generated code was causing more problems. So we'll see how that evolves over time. But this round, no one was doing anything specifically different because of that. Another cross-cutting takeaway was that one of the tasks is about having a comprehensive asset inventory, which is machines and endpoints and components and tools and everything involved with the software development process. And the average adoption is 0.41, so it's halfway there. But I would say if someone's a tool vendor, this is a problem that could use some attention, because there's so much ephemeral environments of containers and cloud and things that come, components that come and go that really people don't even know how in the world to manage their asset inventory because it's so dynamic. So backing up for a moment, I'm going into the US focus of supply chain security. I mentioned already that there's an executive order. In the executive order, if you wanted to sell to the US government, then you had to produce a software bill of materials, and then more recently a focus on attestation, which is the bottom right. So there's an attestation form that now a CEO, I believe, has to sign to say we follow good development practices. So there's a lot of focus now on attestation and the SSDF. And that's great. I mean, it's great for the whole industry that people are really focused on improving their software development practices. It's great. But, I'll go back through and really give the point of view that even more needs to be done. And so up at the top, just as a little segue, in some of the attendees from the beginning, from the 2021 summits, have really had the sentiment the executive order is forcing industry to adopt security practices that should have been adopted 20 years ago. And so that's great that the EO is doing that. And the further sentiment is we want to actually be more secure or to reduce supply chain risk, not just comply. And so that's a great perspective to have. And so if I take you down, what I view as the progression, for many years, I've been in security for quite a while, there's always a struggle for software security, building security in to be a priority. It was always about functionality, security, seconding. But now with the executive order, then, it brings more to a head. In the third bullet there is the executive order. I mean, the first thing out of the chute in 2021, everyone thought the executive order was producing software bill of materials, like those were equated. And then now that it's not just the software bill of materials, but also the self-attestation that needs to be filled out to sell to the US government. Now it's also in self-attestation. Self-attestation is mapped to the SSDF, which is this SBOM and more. So that's great to make it even bigger. But, when I did these studies, and what I'll show you is that there's lots of really important practices that are not in the SSDF that we also need to focus on. So the focus needs to not just be on the SSDF, but beyond. And so what I'll talk about, and a lot of this is repetitious, but what we would not know if all we looked at is the SSDF. And so I had mentioned before, the components and containers pretty much flow freely into an organization without vetting or pre-screening. And I showed you some of the tasks that substantiate that. And so still today, for the most part, developers can go get what they want to bring it into their environment and do whatever they want to do with it. And maybe it's scanned in the first time it's built into the main product. So none of the vetting components and containers is in the SSDF. Still, a SolarWinds type of attack through the build infrastructure could happen pretty easily because none of the SSDF tasks focus on what would prevent a SolarWinds. And then another observation, almost no one is requiring SBOMs from their suppliers or using an SBOM to react to security incidents. So everyone is just focused on getting the checkbox. So, a tool vendor kind of standpoint, how can we actually leverage the software bill of materials for good? At this point, not so much, but using the software bill of materials is not part of the SSDF, only producing. Another observation, if we only looked at the SSDF, is the screws need to be tightened on security requirements of third-party suppliers. So pushing the suppliers to do the same thing that the US government is asking the primary suppliers to do. And then also attack vectors that could lead to unauthorized or accidental access and alteration of product artifacts would still be viable because none of those tasks are in the SSDF. But in the happy note is attack vectors through the development environments are pretty secure. So that there's a lot of tasks that are not focused in the SSDF there are a lot of tasks that are not in the SSDF about the secure development environment, but actually they're doing pretty well. So IT organizations are pretty well on board. So overall, just a call to action that what I see in general is that the tasks that have been more adopted are things that have been around for quite some time, but the tasks that specifically need to close down the novel attack vectors that have been happening in the last few years have not been adopted so much yet. And then, you know, there's a lot of need for tools to make securing the supply chain easier, so that a lot of these things can be done. I mean, you know, the poor developers just keep getting more and more pushed on them that they need to do, and including the supply chain. So we have to be able to develop some tools so that their job doesn't just keep getting harder and harder, and we can secure the supply chain more easily. And just as far as some thank yous, as I mentioned, I did this a lot in conjunction with Synopsys. And so these are some specific Synopsys colleagues. I also worked a lot with folks from Yahoo, so I mentioned them as well. NIST, Karen Scarfone from NIST has helped me quite a bit. I thank all of the interviews and the summit attendees, and NSF for the support for the S3C2 Center. I do have some resources. I'll put this up for a bit. If you want to, this is the full view of what the framework looks like. You know, there's a task name, an objective of doing the task, a definition, some questions, and the mapping. And so this document here is all 73. If you wanted to take a look at that, there is a 1.0 version yet that I'm not quite distributing, but it's close. And then if you want to look at any of the summit reports for the summits we ran, you can get them there. And so now I'll open the floor for questions.
Thank you so much, Laurie. Like, this engaging, illuminating talk. So one of the questions is actually if you can make your slides available
Absolutely.
to the attendees.
Yeah, absolutely.
And I see that you also made available a link for the framework. Like, what about this study, this paper? I believe it's going to be a paper, or is a paper, something with the study.
Yes.
Not available yet?
Not available yet. Stay tuned.
Okay.
Yes.
Okay.
Yeah.
So questions are coming in. So one question here. Typically, once an attack vector is identified, we might see growth in usage until the hole is closed. But that doesn't seem to be the case here, right? Can you speculate on why that might be the case?
So, I mean, I do agree that with the first part that, you know, so the attack vector has been identified and there is growth. There's growth in all of those, you know, so there's growth in the use of components as a weapon. There's growth in using the build infrastructure as an attack vector. I don't think we have results on necessarily on the LLMs as an attack vector, but those are all the new attack vectors, and there's growth, period. It's not closed down yet, which is those, you know, danger zone slides that I have. So it's not easy. It's not easy to, you know, close down. I mean, you know, there's a lot of novel practices and a lot of work that needs to be done, but we haven't done it yet, which is really the message.
Okay, thank you. So another one, can you please define what you mean by open source? It's the GNU or an open source license, or it's just any software binary outside the organization?
Yeah, it's a good question, and I won't be exclusive. I'll be inclusive to say, you know, software that is freely available for use, you know, that to an organization. I'm not going to limit it to any certain license.
Okay. So another one here. There have been some pushes, particularly in the European Union, around imposing security type requirements on open source distributions. What are your thoughts on the balance between open source development and security issues?
I don't know. I mean, so, you know, in the European Union, it's to be determined what will actually come from that. I mean, a lot of the focus in the European Union is on liability for open source contributors, and professed zero tolerance for vulnerabilities. It just remains to be seen what happens with that, because we all want to have zero vulnerabilities. We've wanted that for a long time. So I can't see that it can truly be practical. That people can start being sued if it happens to be that they accidentally have a vulnerability and or bring something in that all of a sudden it has an identified vulnerability. I do believe and have believed for a long time that developing secure products has to be a prime interest. And it is very possible that a lot of the open source contributors are just trying to do their best and give something out to the community that they developed on their own, and maybe not be completely secure. I mean, we don't know the motivations and practices of all the open source developers. Hopefully all of this view of what can happen to the components will make the open source developers more cognizant of the need to develop secure components. But there's a lot on them. I mean, there's a lot of focus now on the larger ones and big companies contributing millions of dollars to identify vulnerabilities and fix vulnerabilities, to maybe provide some compensation to some of the open source developers for these really strategic and critical components. But lots of the things that everyone uses are not among those. I mean, those typical product could have hundreds of components, and we just don't know, a lot about what's going on with those developers. And the developers could be totally moved on for years, and we still adopt their components. If that didn't answer your question, please ask another one.
Sure. So some participants are reporting that they're experiencing errors with the QR code. I wonder if you could later offline send me the links so that we can distribute to them. They are really interested in your slides and everything, all the artifacts.
Yeah, so I'll check the QR codes again and before I post the slides.
Okay, so more questions here. What are the plans to community training and capacity building of open source developers? The big names are producing very expensive courses for layman developers to afford.
Yeah, so I have not done this training, but OpenSSF, which is part of the Linux Foundation, so it's a nonprofit organization that is focused on open source and very focused on security. They say they have, I think, 2 courses. So I would definitely take a look at that, those courses. I think, yeah, I mean, I would look at that. I teach a software security class, and sometimes when I'm looking around for different resources for my class, I'll see little course modules and whatnot. So I think if people wanted to be creative, they can probably find some courses. But number one, I would go to the OpenSSF course.
Where do you see this research moving forward, and what should be the next steps to improve software supply chain security?
Yeah, so I mean, as far as this particular research, and I think that, so there's an analogy some people may relate to, which is the Building Security and Maturity Model, BSIM, that came out of Cigital, who was purchased by Synopsys. So the spirit of this project is very BSIM-like. And so I would love to see this work just continue, and we could watch like a year from now, how are we doing? 2 years from now, how are we doing? So that's one aspect. But there's other aspects that I personally would like to pursue, probably so the top being that now there's 73 tasks, and one way of a maturity model is like level 1 being like the most basic, and level 2 being, the more advanced, and level 3 being the most advanced. But really what I think is important is reducing security risks. So like I'd like to have level 1 be the most important thing you need to do to close down the risk. And, and so have it be backwards by level 3, maybe that's, the icing on the cake. In order to do that, then I need to map the tasks to what are the attacks that are underway and what the attacks that are underway, and then the tasks that would have stopped that attack. And then having those be the highest level. And then even beyond that, having a natural language processing, an NLP of what's going on to tell us what are the trends, and then the trends that map to the tasks, and then, a risk management framework around this based upon what's actually happening. So that's what I would love to do going forward. But, as far as the more general question of supply chain security research, and, we are so pleased to be able to be supported by the NSF. And we have within our center, and I guess I can take these QR codes that are not working anyway. I guess I can take them down. So, within our center, we have in the US 6 researchers, and then we have one person who started with us, but then she moved to Germany, and we replaced her, but she's sort of still with us. And so we are doing, all kinds of research related to the different attack vectors. So we have research stream on the components and how do we shut down that attack vector, and another whole thrust on the build infrastructure, and then our outreach to industry, like, the summits and measurement of what's going on in the ecosystem. So, we are a really comprehensive group and love to collaborate. And so I will put an invitation out. And like, I just went last week to Copenhagen to a supply chain workshop, and still felt very pleased that we're the biggest one. So thank you, NSF, for your support. And so just open invitation that if you're a researcher in supply chain, we meet quarterly, we have outreach events. We would love to have you work with us and, participate in our meetings and talk to us about what you do. If you're a government organization or an industrial organization, and you'd like to be involved with one of our summits, please contact me and let me know, and we can work on that. So, we like to view ourselves as a collection point so that we can really be involved with all kinds of things related to supply chain security research.
Okay, so the next question is for a participant that was very excited about your talk. Thank you for giving this talk, Laurie, exclamation mark. Could you elaborate more about your studies that have focused on gaps in vulnerability disclosure?
Gaps in, so the gaps in vulnerability disclosure. I haven't done studies specifically focused on gaps in vulnerability disclosure. I think that related to the questions on vulnerability disclosure, I think companies are doing much better. Like, I don't know if I'm right or not, but I feel like the adoption rate of specifically vulnerability disclosure is 0.86. So it's among the highest. It was in the top 10. So as far as gaps, what people weren't doing. So for the most part, all 9 companies were doing a really good job. As far as gaps, I think that, there's just something related to it, not putting out a security advisory or not making it known publicly as soon as they possibly could. But I think companies really got, these 9 anyway, really understand the need to be transparent as soon as they can possibly be, and not too early so that they're leaving themselves open for an attack, but transparency once they know something, because they understand the press of not disclosing is way worse than disclosing. I would say also that these 9 companies really had their act together. So are there companies that don't disclose? Probably.
So another question here. Creating secure software has been a problem for decades. There appears no closer to resolution now than any time in the past several decades. My question, what if any role do you see AI fulfilling?
Yeah, and so, I mean, I'll start from the first part, that I do think that the executive order and the SSDF, like, I think it is changing things. I do absolutely see that companies are getting better at the adoption of software security practices. Like, so I do think it's getting better. The role of AI, I mean, there's potential for AI in lots of different areas. I mean, I guess primarily in vulnerability discovery, and so discovering vulnerabilities that are there, and then looking at the output of tools, whether it's any of the tools, software composition analysis, static analysis, any vulnerability discovery tool that has a lot of false positives. I think AI can help with sorting through that. And developing, like, identifying trends that should then be put into rules within our tools. Because the rules in our tools are based upon the past, so we need to be looking at what's happening in the future.
And another one here. Software typically comes with a hash value, enabling end users to verify its authenticity before installation. However, there isn't a reliable method for users to authenticate the associated dependencies in the same way. How should users handle these dependencies in such case?
I mean, they can, I mean, I guess one thing that could be suggested is requiring signed commits so that they can at least, identify tampering that happened along the way. But as I mentioned, that was one of the least adopted tasks. So people aren't doing that yet. And so, like, I think there's a gap there, that people aren't asking for signed commits and signed artifacts yet. And also because of that, people aren't doing it. So, like, there's not a demand, and so it's not happening the way it should be. So that's really my recommendation for a task to adopt.
So one question here is asking whether does this thinking shows up in undergraduate curriculum?
So I won't claim to be the expert for beyond our own university. I mean, we do have a security concentration, and four of us at NC State, four faculty at NC State are in this center, and so we're all putting it in our classes as much as we possibly can. So, like, and making artifacts available for other educators. So if you're an educator, we're happy to share with you. The one thing that one of the summits did say was that they didn't believe that the undergraduates were really taught how to build securely. So how to use the, CI/CD pipeline and associated tools to build securely. And that might be something that I would say we do need to beef up as a community. How do we teach our undergraduates even that line of thinking? Because we don't even necessarily require in the classes them to understand that much about the build process in the first place, no less secure build. But little by little, all of this can get into our undergraduate curriculums.
And the last question, because I'd like to give 5, Laurie has another engagement with NSF. She needs to change Zoom, and I'd like to give her a bio break. But, like, I think a last quick question that came in is, if somebody would like to collaborate with your group, what's the best route? Should they email you? What they should do?
Yeah, email me. Yep.
Okay. Yeah, so it's 5 to the hour.
Okay.
Thank you so much, Laurie, for your, again, illuminating. I have my questions, but I of course, I need to let the participants, as I probably reach offline because I have so many questions after hearing your thought. Thank you so much. And thank you so much for all the participants that are here that asked your questions. I hope you have learned something about open source software security with one of the leaders. World leaders in the field. Thank you so much.
Yeah, thank you for your interest and attention.
Bye-bye.
Bye-bye.